session. So we're earmarked for an hour. Got a lot to get through in this 1 hour. So I will just start the webinar now. And I want to start just with a wee PowerPoint presentation. This will not be a death by PowerPoint webinar. It will be using the software in the anger. But this just gives us a great idea of where the software lies in our system. So we have three different product ranges. We have the big building design suite, multi-story buildings, large buildings. We then have this PowerPad, which we call the light suite, ideal for small companies, companies just getting into the MasterSeries, sole practitioners, ideal for them. Or for those who don't fit into either camp and just want to, for example, I just want to do steel design, well, maybe a customized system would suit you better. But today we're going to be looking at this PowerPad suite. So PowerPad consists of analysis. So it's actually taking our modules in the system and giving you limited versions. So we can see we can have frame analysis of either 15, 100 or 500 members. We also get portals and the office tools. And connected to that, we can then do our steel, concrete, timber and connection design, fully integrated, taking the data and the results from the MasterFrame and designing them, and in the case of some of these, sending those values back through to the model for rechecking with the new sizes. We also include in the PowerPad standalone versions of some of our software, the Masonry retaining walls and the Composite are very, very popular, and also the pile caps. So what do you get? Well, in the modeling you have a single multi-material environment in steel, concrete, timber. We can do beams, columns, trusses, frames and portals. It's not limited to one type of member, and you only learn one system because it's so easy to use. And from the analysis point of view, where you're going to be using the frame analysis or the portal for those elastoplastic portals, or for the simple stuff, the beam designer. From a design point of view, we can switch between the Euro codes or the British standards, and it uses a single common interface with all the different design components. And as I said, there are several versions of the PowerPad. So the versions we have is the standard PowerPad, which will give you 15 member frame analysis and steel design. The Plus, which works up to 100 members, which is our most popular. And for those who are looking to do something bigger, you get the 500 member version. And then we also have a student license version, which is a 100 member version, licensed for a year, which you can renew, but it is watermarked and not of any real commercial use because of certain limitations on it. But certainly any students, feel free to go on and register for our student edition. Who's using the MasterSeries? Well, as you can see, quite a lot of people. You're talking about your Waldecks, your Watermans, your Robert McAlpines, your Atkins. You're talking about your smaller organisations such as 3E. They're, I think, got 2 offices. Your Nicholas O'Dwyer's, your Andy Manns. They're all using the software to great extent. So I'm just going to continue on now, and we're going to go straight in and do some real design. So here's the program, and the first thing you'll actually notice, top front menu, there's no mention of PowerPad. That's because the PowerPad is actually built up of all those programs, so we're using the real programs in the background. If I want to do frames, I go to frames. In frames, I can go in and I can choose to create frames. But before we do that, let's have a wee look at the range of frames that we're handling. Now, you'll probably seen the little image on the website, and if I just wait for it and scroll across, it's probably this side. This one here, we can see our beams, simply supported and continuous. We can see trusses, we can see trussed rafters with rigid members, we can see portals, we can see concrete frames, we can see ground beams, more trusses, and a compound steel, concrete and timber frame. So we've got quite a range of things that we can actually do. But here are some typical frames in the PowerPad. So you have your A-frames, your trusses, very simple trusses, ground beams, concrete ground beams on piles with little cantilevers and continuous beams and the likes. Simple plain frames, uneven towers. A plain frame in concrete in this example, and you can see we would be designing those members as single spans, so compound, what we call super members. And even in the frame analysis we can do portals. And here's a 3D frame. And industrial frames. A truss with somebody playing around with one of the node points to reduce it, and a simple frame. There's a couple here that shouldn't be in this on the flat slabs. They're not available in it. So as you can see, this is a house with inset columns, and then we have a escape staircase where obviously this beam here is supported off the main building, and then we have external columns coming down. So we've quite a lot of different things we can do. So let's take a new frame and we'll just call it PowerPad Demo 1, and we just create this new frame, and immediately we're given a preprocessor. So what I'm going to choose is multi-story and grillage, and that allows me to start from something. So I'm going to say I'm going to have 3 spans. 2 stories sounds good to me, and I'm going to have a deflection, a default span of 8 meters, and the height's 3.5. That's all good, and we'll just put in our basic 5 kilonewton dead and our live to be 4.5 with a 1.5 service and 3. And we will assume that this is simple construction, so pinned beams, and say proceed. What I'm now going to do is play around with the geometry, and I'm going to very quickly delete, sorry, not a node but a member. I'm going to delete this member and say proceed. And now what I'm going to do is geometry, and I'm going to add in a Fink truss. So at the minute my Fink truss looks to be a bit big, and if I ask for the coordinates of that, I'll see that it's 20 meters long. I want to multiply that down to be 8 meters, so I need to reduce it to 0.2. So what I'm going to do is, first of all, I'm going to say it's going to be 8 meters. So there it comes, and the height is going to be 3 meters. Sorry, wrong field. 3 meters. That looks a wee bit tight, so I'm going to make it 2.5. And now I want to get that up there. So what I'm going to do is go to origin, and I am going to say shift that by X 8 meters, by Y I'm going to say 12 meters, so it's up floating in the air. And you can see I can also scale the frame in here, but luckily because it was a preprocessor I was able just to give it the dimensions. So going back to the frame data, I'm able also to tell it to pin all the internals, so all the internals are pinned, and I'm going to say proceed. So now what I want to do, geometry wise, is I want to take off the 2 supports that are coming in with it. So nodal restraints, static supports, and I just scroll through the different combinations, not those, not those. I'm going to delete that one and delete that one. So I've now just got the 2 sets, the fixed bases plus the side restraints, because I am doing it simply supported and I have no bracing. But I'll actually get rid of these as well. And I'm going to make these pins, so I will need to put some sort of bracing into the frame in the form of X bracing or something like that. So what I want to do now is I want to merge these two together. So I'm going to change by shifting this set of coordinates, and I'm actually going to shift it, rather than giving it displacements, I'm just going to say move that node down to there and proceed. So it's now slipped in place. I want to reduce these two end spans, so geometry, shift everything, and I'm just going to shift this, and at the minute these are 8, so it's 8, 8 and 8. I'm going to make these down to 5 meters on the two ends, so I want to shift this in the X by -3, and I will say proceed. And of course I forgot the truss, so I just do an undo and reset. Take off the lengths, I don't need those now. So I'm going to shift everything from this point forward, and I'm going to shift it by the -3 and proceed. Reset, do the same over here and proceed, and you will now find that it's 5, 8 and 5 meters. Now it would be nice if this rafter here came down in an inclination, so that's quite easy to do. So what I'm going to do is go to geometry, and I'm going to go to position on straight line, and I'm going to say reset, take this member, so it's nodes we position on the straight line. Let's take these nodes, was actually really only that one we're interested in, and position it on a straight line between this node and this node. Now what I'm going to do is going to retain my X, and that means that this won't move other than vertical, and you'll see that that's coming down quite considerably in that instance, and I'm going to say proceed. Now I'm going to do the same on the other side, but this time I'm going to build it up myself, just for the fun of it. So I'm going to go into geometry, and I'm going to define some new members. First thing I want to do is actually get rid of this member. I can delete them by using the delete function that I did earlier, but in my case I'm going to put it and not come down the whole way, because I want to put a wee balcony in there. So I'm going to come down here, from here, and you can see I can automatically come along a distance. So I'm going to automatically come down to here, and then I'm going to put a member in here. I'm going to put another member vertically up, and I'm going to say it's going to be 1.55 meters up. So I've created a 1.5 meter hang. Now instead of putting the member there, I could take that out and I could put it over here. And that shows you how simple and easy it is to create additional members. It's very, very simple. Any member can be created, and if I just look at what's happening here, I've got a mid-span. I can go along, in my case, I think it's at 0.25 of a meter, and this one is the third points. I can come out and I can say give me to the mid. I can also say give me to the third or to the perpendicular, which is very, very useful. Or I can hover over this one, for example. Hover over this member, and I should be able to get parallel to it if I really want to, and I'm coming in with that parallel just there. So that's the parallel to it. So I have all these fancy functions, and it's just like an AutoCAD. If I come into my editing, you will see that I have grid spacing, I have object snaps, midpoint, third points, and 0.25. I can say at 0.1 of a meter along. I can also do tracking along members, and I could say track at every 30 degrees plus 1 at 12.5 degrees. And I had turned off the parallel to line the previous time, and I think I probably need to see it back in front view. So now I can come along and I can say give me something that is from this node down 1.2 meters. and then come out horizontally or perpendicular or whatever you fancy, 30 degrees. And I can set 30 degrees, and I'm not going to finish this off at 30 degrees. I could come out a distance, say, of 1.225, and it would draw that. So very easily I can create any geometry I want. Obviously I also have recourse in the system, and I'm just going to go back to the editor to doing importing from so file, exit MasterFrame. Okay, no, I could have started from a DXF file. So I can bring in the DXF file. I shouldn't be able to bring in the IFC. So I could go in and find a DXF file and bring that in. And obviously some of these have been sent out, which might not make sense, but I can certainly bring files in and see what I get. So I could import a frame, and I'll see that I've got concrete, I've got steel sticks. I'm just going to bring them all in and see what I get in the steel area, and just bring this in, extract, and see what it finds. So it found nothing on the layer that is of interest. In okay, let's try center lines. That's always good for finding members. Yeah, it found 84 nodes. I would obviously know in advance which layer I want to bring in, or layers, but in this case I'm just playing around, and I can just say load file. And in this case I've just got some center lines that are random on the screen. But if you've drawn something in AutoCAD, you can then bring it straight in. So no worries there. Now, let's go into a frame that we've already worked done and look at the design component. So let us look at that compound portal frame type building. We'll take this one, and we will see that we've exactly 100 members. So Masterport Plus is what I require. I will see that I have steel superstructure, I have a concrete frame in the front, and just because I can, I have 3 timber sections as a little canopy porch. So this isn't a real frame, it's just to show you the scope of everything. So let's look at the data, and we will see not just the steel properties, we can actually turn on different colors for different section sizes. So we can see in this immediately that that's very thin and that's not, so that should be the same as that one or that one. So what I can do is go to properties, steel sections, section sizes, and I can correct that. So I can take this one, for example, and I can then copy it onto this one, and it knows the sense, and I'm going to copy it on here and on here. So all 3 of these, and it's just actually taking it back off, all 3 of those now, all 4 of them have the same section size, which makes life a lot better. So actually looking at those section sizes, it's worthwhile seeing what we can do with our properties. We have our steel sections, so if we take any one of these members, we'll see we have our standard UBs, UCs, RSJs, IPEs. We also have, if we look at this, flats, so we can specify flats. And I think in a global fashion, I don't think that I want them to do 450 by 12. I think that should be 150 by 12. So there they both go down to a smaller size because I did it in a global fashion, changing both of them at the same time. If I then go to member mode, you can see that I've got a beam that has a cell form with some openings filled in. So somebody's been very, very diligent, and that's all part of this PowerPad. You'll also see that I might have a beam that's built up. I don't, but if I wanted to, I could come along and say, well, actually, I can't go as deep as 500 here, and 30, I can only go 500, so let's make the beam 500. So a welded up section by 200 with 15 flanges and a 12 web. Well, actually, the web would probably come down to more like 10. So that's a built up section that we've done here on this member. We can also do encased sections. We can do compound sections. So if we wanted to, over on the right hand side, we could take these columns down here and we could say, actually, we want to put in a secondary beam that is a giant UC, probably, or UB, probably not. Something along the lines of the 254 by 102 would be a more sensible section to fit into the web. And from an analysis point of view, it doesn't matter that it's on the left rather than the right side. But that is, again, something we're able to do with the sections. We also then have the concrete and timber, so we have the T, the rectangular, the square, the circular, and the L-shaped sections all in the concrete. If I was to move over to here, we can see that I'm now looking at a timber section, sawn timber, and we've been told to use A1 in the Euro code. We can also, again, do a lot more with that as well, internal use, things like that. And that is the steel sections. Loading wise, what have we got on this frame? Member loading. I spend time on the frame analysis because to me it's the core of the system. If frame analysis isn't the most important thing you're interested in, then maybe you would be looking at one of our custom systems rather than the PowerPad. So just turn off the 3D coloring, turn off the 3D itself, back to our wire frame, and we can see we now have our loadings applied to the structure. So if we look at any of the members, we will see here we've got our UDLs and our point loads and our partial trapezoidal loads all defined on the members as dead or live components, and we put some loading on the roof as well. So I'm not going to waste time going into all that today. What I now want to do is to look at loading combinations. So all cases, if I go to loads and go for loading case titles, we will see that we've got 21 cases, including serviceability and notional. And somebody was playing with composite at one stage, so there are some composite cases which will not affect my steel design. I could delete those and come back to this case 4 if I wanted to. I also have a loading case generator, which will allow me to say, and we're working to the Euro code, so it's saying for dead plus live we want set B, so 610A and 610B. For live load only, it's surface. Dead load only, it's surface. Dead plus live plus wind, it's A and B, ultimate. And equivalent horizontal forces applied as well. And for dead plus wind, it's ultimate and surface. And so I can then say regenerate those. And if I say regenerate, I will see now that I'm down to the 19 loading cases in the different directions with the W1s and the W2s, because it knows it hasn't given me, we haven't put on wind loading on the other directions. So those are some loading cases, and all done very, very neatly. It has also automatically done the equivalent horizontal forces for us. So everything is done. All I need to do is analyze. And I'm about to move into, and it's a space frame, program 2 in a moment of all of our programs. At the minute we've just been dealing with the frame analysis, and obviously bending moments are very important to be able to see all those. We can scale them, we can put in the number of increments to make it nice and neat. We obviously can zoom and pan. We can actually, of course, we can put values on major axis only. Let's look at the bay one left, and we can see the diagrams on it. Let's look at the first floor, and we can see on that all the diagrams on the concrete first floor. Or let's look at planet level 1, and we'll see all of the values there. We can turn off the 3D, and we can get our forces, and we can create our own views, obviously. But you have your bending, your deflected shapes, and everything. You can see there's continuity here because it's concrete, and we're getting the continuity over the supports, whereas these are all simply supported. So again, we are on a whistle stop tour, so we've seen our graphics. I'm going to go back out, and this is where I want to go in to my second program, the steel design. So in Blue Peter style, for those of you who are from the UK, it already has some design checks applied to it, and if I look at any of the rafters, we can see that the rafters here is passing. It's doing the axial with moment at all the different purlin locations and saying, yeah, they're okay. It's also doing the appendix G and saying, well, actually, yeah, we're okay as long as we go from, we have a restraint there. If I was to come down to my torsional restraints and remove the first one and make it span a bit further, it's going to say, no, 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 I need that restraint, it's failing. So I can say, right, we'll put a restraint in at 1.8, and then let's look at the rest, and the rest is okay, so we don't actually need a second stay. We only needed the stay at the very start, and we'll put that out at 3.6 because it'll be past the point of counterflexure, assuming 1.8 meters purlin spacings. So very simple, very straightforward design checks, and obviously we can look at design checks that we haven't specified already. So let's go for a discontinuous strut on these members, and we'll see that, well, we didn't apply wind loading in that direction, so we don't really have any design on them, but it is telling us that they are okay, which is quite reassuring. If we look at our large columns, we should find that we've got design on those, and it's telling us that, you know, the axial is not really a big problem. It's the lambda, it is the slenderness ratio. Now in the Eurocode and in the more recent BS, you don't really have to worry about the slenderness, so we can ignore slenderness limits because it'll be down to a very low stress that's admissible. So we can see that we're coming down, and we can see that we're using very, very little, and our utilization is tiny because the loading isn't very high on that roof. So that's well in. Now we also then obviously have the beams internally, and they are, well, sorry, I should be in search mode. Going to beams, and we can see that these beams were in fact sized a bit more rigorously, and we're saying we're sizing the full beam, the super member, the two component members joined together, and it is failing. So how do we design a member that's failing? Well, it's very, very simple. You can take your section size. If it's restrained over its full length, then that's one criteria. Let's see what our criteria is. Axial with moments, it's fully restrained, and I would argue that that is not fully restrained. It is in fact because it's 1L and has restraints at the intermediate beam, so it's only going to be restrained at the midpoint, which still makes it fail, obviously. And we can see our unities here that are failing. Section size, we move up 74, 85. The 533 82 kilograms works in a 275, but obviously I might want to work with 355. So I could come down and find out which one is the lightest one that works, but we always have this auto size. So auto size tells me that for 355, the shallowest section is the 457 at 98 kilograms. If I sort by weight order and repeat, I can get the 610 at 82. So in a big frame may be a saving you want to take out. In a small frame you may want the squatter, more robust, more readily available section to be used. The choice is yours, and obviously we don't have to just do one member at a time. We can go through and size all the members in the frame, so it's now sizing through the design of that frame. Obviously something has annoyed it in the sizing because it is, there we go, it's got passed. So now it has sized all the members. You probably would at this stage reanalyze to make sure that there's no redistribution of forces, and then you would scan all your design checks to make sure there's no failures. So it's done 10, done 20, no failures, done 30, no failures, halfway there, 40, no failures, 50, no failures, 1 failure. So there was 1 member that in the changes, and it's one of the bracing members, and it's failing by 6%, and I would say, oh well, that's going to go up to 2.9 at least. And I wouldn't like to see anything less than a 3 or a 3.6 anyway myself as a wall thickness. So that's your steel design. Very simple, and we can print all that out. But I'll show you some of that later on. If I now just reanalyze the frame, because I did change that section size, space frame, it's very, very quick. So we're now going to move into our 5th set, because we were looking at eye sections, hollow sections, and angles, channels, and T's there for any of the bracing and everything. So we're now into our concrete design components, and in this case we have quite a bit of concrete. So let's move to the front, and we'll see that we have a beam that we do not have enough reinforcement in. So I can, again, just using my mouse, increase my reinforcement and increase those to be whatever, and it's the bottom I need to increase. So 320s, 420s would work, and we can see a little bit of a failure here. So I could take these bars, pull them out a wee bit more, and take these support bars, make them into 16s. So if I'm going to work with a cage of 3, so I'm going to pull this down to 3s, and that is just in no more working with no additional reserve. Now I just need to make sure that it knows that the next span, sorry, I clicked on that. There we go. Also uses the 20s. So as we come back, now there's just a wee bit of a lapping problem here, because obviously it's using the double reinforcement. So in fact actually the 320s plus the 12s is giving us additional capacity. So really we want to push that up to either 25s, or we could come along and we could redistribute that right hand by 5, 10, but obviously that then puts onus on the bottom steel. So in my case I will not redistribute. I will actually go up to 325s, and if I was trying to be very economical, I would take that label and split it into 2 and make it 125 and 220s, or if you prefer your big bars on the outside, 225s and 120. So we have this full recourse to curtailing our design. And likewise for our columns, we have a failure here. It's just a wee bit unhappy with its capacity, as you would expect with such absolutely tiny rebar in it to start off with. So I'm going to go up to say 20s, and I'm going to put in a couple more, and it's still not liking it. So yeah, we're still way over by a ratio of nearly 2. So we're going to need big bars in this because of the loading that was put onto it. So 32s, and clearly we should go for maybe a larger diameter. Let's see where we're at now. and now it's the percentage of steel that got too big, 25s, and it's telling us the moment capacity is failing by 10-15%. So what we could do is we could put one more bar in. That should do the job. Nearly 2 more bars in. Oof. So we're still not there. So the size probably needs to go up to 500 size, and at this stage we could reduce our bars down, say, to 725s. So if we go up to 32 bars, we could get away with 5. That's 5 plus 4. That's a total of 9 bars. Will we get away with 8? We would get away with 8 32s. So total of 8 32s would work there. And obviously I can come along then and do my pad foundation when it gets around to it. But you know, we don't have to do all this sizing manually like everywhere else. We have these auto design facilities that's telling me a 230 by 235 pad, 450 thick, is giving me, and it has all the starter bars listed, 8 32s pitched on circle. So everything is tying in lovely together to do this. Now what I want to do is say, yes, we can go and we can design them all. We can redesign all of the members that are concrete quickly, and it's running through, doing all those, and it's coming up with the final solutions. And it got a little problem here due to, in my case, I put some off-center member loading, and it's got a torsional problem, which is unhappy about in this member. But here, it's all okay. So we'll see that we have a little torsion that we would want to get rid of by going for bigger sections in this case. But once we've got our design, we can print this out and off we go as happy as can be. We can take our output and we can export it as a DXF file straight out to, I'm just going to skip everything. My intention today is not to do complete designs, and I'm just going to export those, yes, and export, even though I'd never solved the problems. It's now loading AutoCAD on my other screen, which I'll pull across to you in a second once it's opened up. There we go. So there we have our B16s, 01, and our B08s for our links. And you'll notice that we will end up reusing bars as and when we need them. So 08s have been used here and here, but this is 7s, and these are different because it's a different width of section. And then we have a little bit out here that is actually not concrete, that we don't consider. Actually, that's part of that cantilever for the entrance. And then you have your ground to first columns, in this case very, very simple and boring. And then you have your pad foundations, and as you'll see, with all your starter bars in that. So yes, it does work. It does export to AutoCAD, and I'm just going to say no and close all that. Frames, steel, concrete. What's left? Back to frames. One last thing we want to look at, integrated, and then we will look at the standalone programs. So if I go to recent, that's my frame, that's my frame. I also have access directly to connection design. So rather than standalone connections, which I do have, that's okay, I'm going to go in and do the connections, and it's got some connections here already, so I'm actually just going to delete them and start again on a few connections. And it won't allow me to do that. I'm going to have to add a joint. So I'm going to add a joint, and it's going to be a beam to column. Very simple. And we'll take this rafter over here, and we'll see that we automatically come in with all the dimensions from the analysis. We just need to lift our bottom bolts. So instead of being at 65, I'm going to make them at 90 up, and 90 is not quite enough. 100, and that little warning goes away. So the connection can be built, but we have a failure here and a failure out here. We are working to the Euro code, and we will see that we need a lot more bolts. We're at 2.7 over stress. So bolt row 2, I'm going to put in 90, and we're down still to 2.7, but we have a symbol here telling us that we actually need a compression stiffener because it's limiting the design. I'm going to put a 12mm stiffener there, and now the joint actually works except for the end of haunch, and this is the one that annoys everybody, the end of haunch stiffener. So basically the Euro code, if we look at the results near the bottom, it uses a simple ratio of ultimate to yield stress, not the applied but the ultimate to yield, times the breadth of the two sections for the haunch and the beam it's coming into. And if that's outside a certain limit, you must stiffen it. Even if the portal has got no actual load on it, you need to stiffen it. Even though there's no stress out here, you need to stiffen it, which is a most annoying thing. So I'm going to slip in a wee 10mm stiffener. And there we go, all 8s, 8 6s, so 6 welds and a 9. And all I want to do at the end of the haunch under welds is tell it the flange weld is also a 6mm, and that told me that for a 6mm that connection's okay. So we have that full integrated connection design. One more connection just before we go. Base plates, very popular, and I am going to choose this little internal column, and I'm going to say for a 152 I'm going to go for 450 by 450. That's pretty colossal. We could actually probably get away with 400 by 400. And then we could spread the bolts out, but there's no need to. In this case we know it already works. We can see it works automatically and everything is fine from the design. So integrate design, I can take those and send them out to AutoCAD. I'm not going to chance AutoCAD again because it's been a wee bit funny. So steel design, concrete design. Oh yes, one more. Design timber. So I could come along and add an axial moment and apply it to this member. But all I need to do is add the briefs and I'll automatically get them. And there we go. We can see that these two members are okay. With the loading I put on the end of this one, it's just a wee bit slender in its default sizes. So let's look at the size and we can see that we would want to change the dimensions of that section. Because it's quite a large span, make that 225 or make this 100 and it would work. Not that you'd really want to be spanning that sort of span in timber, but it's happy, it goes wide, everything is happy. So I'm just going to close down the timber. It's very simple, very straightforward. So that's 6, 7, 8 programs that we've covered. Okay. The standalone programs, what we call the designer suite programs. Very simple. We can do composite beams. So we can do simply supported composite beams, either primary or secondary beams. So here we go, a simple PowerPad beam coming through, and I can say that I actually want the beam to be 8 meters in span and have 3 meters to one side, 2.7 to the other side. And of course we have the options to give you, and it's using RibDeck 80, and we're going to go for grade 355, and I am just going to go and say you design it, and it's coming up with a 305 by 127 48 as the shallowest. And if I asked again, a 406 ever so slightly lighter works, and I actually think it's a better section because it's the 140 wide. So composite is very, very straightforward to do for primary and secondary straightforward beams. And I'm just going to come out of the composite and let's quickly look at the next program, Masonry. Now, we've made big inroads in the masonry design in the last 12 months, and I'm sure some of you have seen the yield line analysis of masonry walls with openings. Now, that is not part of the PowerPad, but one of the things that we like about the PowerPad and our clients like is the ability to say, well, actually, I like that program, but could I have the full version of just that part? So if you're in general work, you may consider, and I certainly would if I was an engineer, upgrading this one to its normal. So I'm going to go not for a freestanding, but a normal cavity wall, and it's going to be 4 meters wide by 2.9 meters high. And I'm just going to change the fixities on the edges here to be pinned, pin top and pin side. And then I'm going to go and I'm going to put some lateral load onto it. So I'm putting a lateral load. Let's make this a bit bigger, 1 kilonewton. And that is actually working, but it's working because it's 190 inner leaf. Let's go to the wall data and let's pull this down and down again, and we'll see that it's still working. So why is it still working? We must have put something onto it to make it work. Maybe it's the shortness of the 400. I think it's probably the 400, or 4 meters is probably a bit narrow. Let's make that 5 meters by 3.5. And now we're not working with an overstressing of 20%. Now, again, if we were in the full version, we would have access, well, to openings, which are no use to us here, but rebar on in the beds. We don't have bed joint reinforcement. So all we can do is either turn around and say, well, actually, it's a bit better. It's actually fixed on the two sides. Fixed on one side is not good enough. It's something that we used to do when I was a practicing engineer, to say, well, at least every other one was fixed, because you would have the continuity every other at least. That's not working. So what do I have? Materials. Inner material is blocks. If I come down and go up again, 17.5 Newton blocks, it works. If I don't want to use 17.5 Newton blocks, since we're so close, we might get away with changing our execution classes. And in fact, I think he already had quite a severe execution class and control class already applied. As you can see, as we start to reduce it down to the more basic category 2, then we have 7% overstressing. So that's not going to solve my problem. I would probably let that go and say it's deemed to satisfy, it's less than 1% overstressing, and no checking engineer is going to fail you on that. But the choice is yours. What I might want to just do is just check what the outer leaf material is. So we're actually in heavily absorbed block bricks, and if I come down to the 7 to 12% absorption, that is going to give us the solution to make our blocks work, our masonry. So very simple, very easy to use program. Now, coming along, the next of these holy trinity of programs is the retaining walls. This is all part of this PowerPad. Coming in, let's take a typical wall. And I can see a wall that is masonry with a wind loading. And my problem is that this sort of heavily loaded wall is screaming out either to be solid concrete reinforced or reinforced masonry. I cannot do reinforced masonry without without the full version. So all I can do is tell it that it's not masonry, it is solid concrete, and at this point in time, solid concrete wall, let's have inner and outer steel. And 16s is going to work well. So 12s at 150, 10s at 150 isn't good enough. So 12s at 150 would do the work. And what have we applied? We've applied a wind load because we've got an upstand on the wall. We've got a sloping back. So we can apply all those things to our wall. Grade 30 concrete. That will be the cube strength. And that's really all I can say. Obviously the wall has a water table at 500 mil up. You're obviously pulling that down, excuse me, makes an improvement to the system. And we can see our capacity here changing due to the water table. And we see that starting to climb up. As we get higher, we're now beginning to get failure. In this case, we're getting failure due to sliding. Well, if that's the only problem, normally with the full version, we would prop it. We can't put props and ties in, but we do have access to a base prop. So we can say, no, don't worry about the sliding. It's actually connected through to something else, and it's not going to slide. You could also obviously go into your materials and give yourself a base coefficient of friction on the base of the and there is a coefficient of friction. If I made that 100, it doesn't move anywhere. 100's a bit severe, 10's a bit light, 20 works. So if you knew that you were going to get a bit of coefficient, oh sorry, not coefficient of friction, I apologize, cohesion as well as normal friction, then that's an option for you. It's not one I would recommend because people have been tramping around this. You've put blinding in and everything, so cohesion, it's going to shear before that. Without the cohesion, it's very difficult in my mind to activate the cohesion here. Cohesion down here, yes, you can activate that and have an effect. So if I said the wall cohesion was 10, doesn't actually fix. That was this wall, the soil cohesion is 10, and it again holds it back and stops your loading from coming up. But again, I'm not a great believer in using any cohesion at all. We're talking granular fills around what we've excavated. So the other solution, can't prop it, can't use cohesion. Well, the other solution is to make the wall longer to give it more load. So by making the wall longer, in this case considerably longer because it was quite a lot of pushover, we can make that work. So that's your retaining walls, your masonry, your composite, the holy trinity of standalone programs. So guys, we are now at the 2 o'clock. What I want to do is just to go over one or two things as a refresher on what we've seen. So clearly we know that it comes in 3 different versions. What am I in here? I'm in PowerPad. It comes in 3 versions, PowerPad Plus and the Pro 500 plus that student link. And if anybody wants the student version, they just come straight into the student. So Home, Product, Light Suite, and then down into the student version. And you will see that you can have a slightly different thing in the student version. And you can request that. For anybody else, you can go to the full version and also request a free trial. So you can get your free trial version from these buttons or from the home screen. Why not just go and try a whole lot of our software and just type in your values, and on you go to the next stage and you get access to all our software. 30 days in your own office to try with full access to the full program. Now, I said that you could upgrade, and it's very interesting. If we look at the price list that would come with anything, you can see that connections, you can design connections, and I'm just going to zoom this up so you can all see it clearly, comes with anything up to 300 kilonewtons and kilonewton meters. The masonry does not do reinforced masonry or openings. So I come down and I look at what I can upgrade. So if I take this masonry, I could add the bed reinforcement, openings, advanced U-line, vertical loads and wind posts. So that program normally costs $1,000 for the masonry standalone. But if you've already got the PowerPad or are buying PowerPad, that will come in at a discount. And the lovely thing is that we can actually further discount that. If you buy it at the same time, you're allowed to upgrade any 2 programs for half their normal discount price. Which means, for example, people who are doing masonry and retaining walls can take the 2.5K plus another 700 rather than 1400 for the masonry retaining walls. We also have others. These are just example early upgrade pairings. So you have full access to upgrade any components, and you can upgrade them at any time. It's just within the first 60 days that you get that double bonus discount available on them. So if you only wanted the moment connections, you can upgrade it for 700 or 350 within the first 60 days. Things like that. So it's fully flexible system that grows with you, and you never lose the capabilities. You never suddenly outgrow it and you've wasted money. If you were to take all the functions in PowerPad and then upgrade them all to their full versions using this little table over here on the right, and then add up this table of the full prices, you'd find that this table plus the PowerPad is less than just buying these individually. So in fact, PowerPad is actually something that I would frequently, if somebody's buying a big system, include just to get additional discounts. Additional discount off the software. So I'm just going to look at any questions you have, and it looks to be a very quiet session, George. No questions whatsoever. One question. Is the truss connected now that it is in the right place? John's actually had to go back to work, but the simple answer, if you remember my little truss that I did, the answer to that is actually yes and no. So if I go to my little frame that I was playing with, I don't know if I actually saved it. I didn't actually save it. But basically, it was sitting with 2 nodes. The node that came with the frame and the node that came with the truss at the same location. Absolutely, and John's recognized that. But when I went to analyze the frame, it would have actually pulled those 2 nodes together and made them into one, and it would have automatically merged it. Now we have a whole lot of little tools in the program. For example, if I did this and I then went into the editor and I went geometry, define a new member, and I wanted to define it from here, and I'm just going to take this out a meter. There we go. And then from there to there. If I then went, so that's one node, that's a second, that's a third node. If I went geometry, change, so I didn't, did I get it? I did. And I take these 2 nodes and I shift them back by 1 meter. Oops, I went the wrong direction, apologize. Minus 1 meter. So that's where I was. And another one. So that's now a coincidence. I now have 2 nodes there. In fact, I have a member there as well. We do have tools to identify that. So I could go and I could say model cleanup, pack, and that will pack. I can also show coincident merge nodes. If I want show, I could then say, show me any nodes that are within 100 millimeters of each other, and it suddenly highlighted these. Obviously, it's better to look at this without the 3D on, and it said there's 2 nodes there. At 10 mil apart, at 1 mil apart, Well, at 0, it's thinking you're not doing anything. So yes, there are 2 nodes there, and you will see if I turn on the node numbers that it's going to go, 1, 2, 3, and then blah 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 all to the end, and then 21, 22. So I'm seeing 21 over the top of node 1. So if I did a pack nodes, would I get rid of that? So I should see that it goes 1, 2, and 21 goes there because 22 is now 21, and it's merged those 2 nodes together. So yes, it is done automatically, but that is also done as we try to export. So if I did an undo, I've got 2 nodes there. I go to restraints, nodal. I'm going to put a wee static support under this one of some sort. And now I go to analyze. It has been packed automatically. And you'll see it's 1, 2, 3, and then that's 21, because it's taken those 2 coincident nodes and built them together. So yes, they were separate. We could merge them ourselves, but the program is so smart that it actually merged them at analysis time anyway. So no other questions are popping up. I see that I still have about 40 people still here in attendance. I am just going to take you to one last thing. When you get your trial of the software and you install it, you'll see here it'll tell you that it's a 30-day trial and you've 30 days left, 25 days left. The important thing to go to is this Learning Center. The Learning Center takes you into a reduced version of our website where you can look at all the videos. So if you wanted to learn about our retaining walls in great detail, you would come along and view that. If you wanted to see the masonry with that fantastic yield line analysis, you can view it here. If you want to look at last year's PowerPad video for when we did it last year, you can look at it. And I'm going to hopefully edit this file and post it up there, and you'll be able to see that as well. So all these are available. So I go in and I say play. You're probably going to hear some idiot like me talking in the background, and I can just run along and take it through and then look at the different components, and as you will see, all that. Now the other thing that I wanted to take you to was, if we're looking at PowerPad, which I can get from here as well, and go into PowerPad, you can actually see the output here, sample output. This is a sample file of calculations straight into a Word document of our output. So you're seeing the geometry we saw on screen, different formats, the loading was applied for different loading cases, dead plus live ultimate, in this case wind load only, so he had gone to the extent of actually applying his wind loads. His data files, which can be a wee bit long, but you don't have to print them. His numerical results, which he summarized, he didn't put them all out. A couple of bending moment diagrams, a couple of deflected shape diagrams, shear force envelope, so if somebody wanted to put that out for a floor plan and give it to a fabricator so that he could design his simply supported beams, all his simple connections. He knows that he needs to design these for 62 kilonewtons and these ones for about 95. We can also give you your axial loads so that you can see if somebody wants to design piles or whatever, what the loading in these are. Steel design, the summary of design checks. These are all the design checks, and they all say pass, which is what you want to see. The ones that are in black were actually then printed out because the guy was bored and wanted to print quite a few out. So there's all those fancy design checks, even in reversal. It's all doing that automatically. I'm going to skip past quite a few of those. You'll then see our connections that we were working with, something similar. What I will say is this output actually was from a while back, so I think it possibly is a Eurocode output. I'm not certain. They just need to. No, it actually looks to be a Eurocode rather than the BS. Yes, it is Eurocode. Somebody has output it. So there's your apex connections, your fancy fin plates, your base plates, and now we're into our concrete design. We're looking at our summary results plus some simple output, and then he's gone down, and what else has he done? He's really, I think, only done this frame, so he hasn't, I don't think. Oh, there's your composite beams, there's your freestanding wall, and your laterally loaded wall internal with some loading on it. There is another wall. In this case, he's actually gone to the extent of opening it this end, so it's got axial load from above. It's restrained in those ends, but not here, so it's free in this end. That's still part of the code design. And then your retaining walls that we're looking at. So this gives you an idea and a stepped wall of what we can actually do in the MasterSeries. And he's actually gone to the extent of doing this as a gabion wall, because he's just put in no reinforcement with a tensile strength of 0 in the concrete, and it doesn't give any failures, so it's actually working. And then we've done some timber, and in fact the pile cap, which we never looked at this morning, and some simple one-way spans of beams. So that's all part of this PowerPad program. So I would love to thank you all for coming along today, and any questions, just email myself, Tommy, at MasterSeries.com, or even email George, and his email is actually just help@MasterSeries.com, and the most suitable person will answer your technical questions. If it's a sales question, you come through to me, Tommy. If it's a technical support, just fire it off to the help guys and they will help you.